So today we will discuss about some problem on the rational equations. So the first problem is like this. The area of catchment is given. Catchment slope is given. Maximum length of travel of water is given. And maximum depth of rainfall, which has a return period of 25 years, is also given with respect to its duration. Now the question is, if a culvert for drainage at the outlet of this area is that watershed, this area is to be designed for a return period of 25 years. Estimate the required peak flow of the river by assuming runoff coefficient C as 0.3 and using rational equation. Okay, so the question says that we want to design a culvert for a drainage at the outlet of the catchment area or of the catchment, which has an area of 0.85 square kilometer, which has a area of 0.85 square kilometers. Now, in case of, they have said that you have to use rational equation to solve this problem. So the rational equation is very simple. It is Q, the peak flow. This is what the question wants. Required peak flow of a river is equals to CIA, where C is the runoff coefficient, which is already given here. This is 0.3 here. And A is the catchment area, that is also given here, 0.85 square kilometer. The only thing that is unknown here is the rainfall intensity I. Okay. And this Q is equal to CIA can be of any unit depending upon the unit of the input parameters. But if you use this formula 1 by 3.6 into CIA, then the unit will be cubic meter per second. That means the same rational equation can be modified to 1 by 3.6 multiplied by C multiplied by I multiplied by A. Then the output of that will be in the units of cubic meter per second. This is actually also known as cubic. So let us return back to this problem. As I said, C is given, A is given. So how to find the rainfall intensity I? As you know that the formula of rainfall intensity is this. I, which is a function of time of concentration and probability of the rainfall, is equals to k t to the power x pi tc plus a to the power n, where k, x, a and n are all constants, and tc is the time of concentration, and I is, as it is very easily can be interpreted, this I is the rainfall intensity, and this I is actually a function of or depends upon the time of concentration of the rainfall and also the probability of the rainfall. And this T, as you know, is the return period of the event for which you are calculating the intensity. So for this problem, the values of constants are not given. So as a result, what we have to do is we have to find the depth of rainfall for the duration which is equal to the time of concentration by the interpolation method. Okay, so I will demonstrate how to use the interpolation. But the first step will be to find the time of concentration by Kirpich formula, because as you know, time of concentration I, to find I, you must know what is TC. TC means the time of concentration. Now there are various equations to estimate time of concentration, among which Kirpich equation is one of the most popular one, although it is an empirical equation. So here the time of concentration is given as T is equal to 0.0194 multiplied by L to the power 0.77 multiplied by S to the power minus 0.285. This L and S is respectively the length of travel of water from the farthest point of the watershed to the outlet of the watershed, and S is the slope of the watershed. Now as you know, in case of watersheds, watershed is something like this. This is the main path of the river. There are hundreds of tributaries and also hundreds of distributaries. Correct? Now the area from where water can come into the lowest point of this watershed, or this landmass, is known as the watershed area. Anything beyond this boundary, any water droplet beyond this boundary cannot cross into this watershed. Well, it may go to this way or this way, but it cannot come here if the water droplet falls outside this boundary. So in this way, the boundary of a watershed is demarcated. Now here, this area, by watershed area we mean the area of the entire watershed. And in case of Kirpich equation, this L, the maximum length of travel of water, is nothing but the farthest point from where water can come into this is known as outlet of a watershed. It can come into the outlet of the watershed. So that is known as L, and slope is your, as all of us know, h1 minus h2. This is the maximum height, this is the minimum height within this watershed area, divided by the distance between h1 and h2. But that means the highest point and the lowest point within the watershed boundary, the distance between them is L. This h1 is actually the highest point, this h2 is the lowest point in the watershed. Now you have to deduct it and divide it by the distance between these two heights. Now this will be your slope. Okay, so in this case, the L and S both are given. L is 950 meter, S is 0.006. You put into this equation and you will get the time of concentration, which will be 27.4 time of concentration, 27.4 minute. So one thing is done, time of concentration is over. So the step 1 is finished. Now the most important step in this problem, it is the step 2, intensity I. How to calculate intensity I. Here what happens, you see the duration and depth of rainfall of this event is given. Okay. So this event has a 25-year return period, and you are required to design a culvert which is also have a return period of 25 years. So So the step 2 will start that, as in this case we have to find the rainfall intensity, but in rainfall intensity we do not have k, x, a and n value of these four known constants. But we do have the value of Tc. We know return period is 25. The 25 year return period is there. And I is a function of this time of concentration and probability P. All of you know that P is actually nothing but 1 by T. So naturally, if you have this T here, that means I, the rainfall I, or the intensity I is proportional to return period T. Okay. And inversely proportional to probability as P is equals to 1 by T. Correct? So T will be equals to 1 by P and P will come in the denominator. Anyway, so what next? How to calculate that? So as you do not have x, a, n, k, so no need to calculate this constant. We'll use the interpolation method to find this I. Now, I can also be written as this depth of the rainfall, maximum depth, divided by the time of concentration. This time of concentration actually it also indicates the duration of the rainfall, because after the rainfall occurs, the point, the droplet, the rain droplets from the furthest point will reach the outlet at a time indicated by time of concentration. So that can be taken as the duration of that rainfall also. Now here you see the duration and depth of rainfall is already given. Now what you find is from time of concentration is 27.4 millimeter. So here you see there is a 20, there is a 30, but there is no 27.4, so we have to interpolate. So when we interpolate this, I think it becomes 27.4. Okay. So now what happens is, so we have 27.4. So if I take only 20 amount, then the corresponding in 27.4, you see it is 27.4 is not 30, not 20. So if I write 27.4 like 20 plus 7.4, so I know I have the corresponding depth of rainfall for the duration 20 minutes, which is equals to 40. So 20 minutes of duration can be contributed to 40 millimeter of rainfall, right? But still there is 7.4 left, right? So with the help of the interpolation method, what we do is we deduct y2 from y1, divide x, correct? And this slope can be multiplied by the remaining amount of duration, 7.4. So you can say that y1 minus y2 here is y1 minus y2. So this is the highest point. This is y2. This is the lowest point. This will be y1. Again, this is the highest point x1. This will be the lowest point. So this y1 minus y2 divided by x1 minus x2 becomes y1 minus y2 is your 50 minus 40. 50 minus 40 divided by 30 minus 20. Okay. this is the slope, and then you multiply the remaining portion with 7.4. Right? So this is 10, and this is also 10. Now 10 will deduct 1, and this entire thing will be converted to 1. So the slope is actually m is actually 1. Multiply 7.4 the remaining amount, right? Then it becomes 7.4. This is the interpolated rainfall, and here this as we I already said 20 corresponding 40, so 40 is available, multiplied by just add the interpolated part, which is 7.4 here. So the resultant will be 47.4. So this is your rainfall, right? Now what I have said, how to find the rainfall intensity. I have said that just divide the depth of rainfall by the duration indicated by the time concentration. So this is the duration of the depth of rainfall in millimeter. So 47.4 millimeter divided by this what I say, this length of the this what is it? So this time of concentration. So this will become okay, and this will be your, because basically I is your depth of rainfall divided by the time of concentration. Now this time of concentration is also known as the lag time required for a rain drop to reach the outlet of the sheets. So this is basically what this is, and rainfall intensity is actually expressed by the depth of rainfall per time of concentration, and that is why the unit becomes millimeter per hour. The unit of rainfall intensity becomes millimeter per hour instead of only millimeter, because in that case, in case of rainfall intensity, this duration of rainfall or time of concentration equivalent is extremely important. So rainfall is actually the magnitude of rainfall, and rainfall intensity is actually the magnitude of rainfall divided by time, or the time with which the rainfall has occurred, or duration of the rainfall, the time which indicates the duration of the rainfall which has this magnitude. So then this is what the intensity is. That is why rainfall intensity has a unit of millimeter per hour. So good. Okay, so when you calculate this 47.4 in a calculator, 47.4 divided by 27.4, which is becoming 1.73. So I will be 1.73. Now in case of Q, we will try to find Q on in the unit of So we try to find Q in the unit of the SI unit of discharge or peak discharge. So which is actually is meter cube per second. And here you see the QP. If I modify the rational equation by rearranging the units, we will find this one 1 by 3.6 into C into I into A. And this QP will be in meter cube per second. So here A is given, A is 0.83, C is given 0.3, and and C is given 0.3, A is given 0.8, I is also given, not given, but we have calculated 1.73. So if you multiply 0.3 into 0.83 into 1.73, then let me see, 0.3 multiplied by 0.83 multiplied by so it becomes 0.249, but however in this case this one is millimeter per minute, correct? This I, when you are dividing the rainfall by the time of concentration, this is minute, this is millimeter. So what we have done is we have converted this minute into hour. So that is why we to this ratio into 60 has been done. Okay. So this will give you the Q in cubic meter per second. So as you see, the equation or the process of solving this problem is very easy. First step is to calculate the time of concentration, keep it formula. L is given, S is given, just put it and you will find the TC. Now estimate the intensity I, that is very important. I, we all know what is I. So this is the equation of I. But I can also be represented as the depth of the rainfall per hour of per hour duration, that is the time of concentration. Okay? So here also you can you have already calculated TC, time concentration, but you do not have the corresponding depth, corresponding rainfall there. So that is why you have to use interpolation method, and this is the table you have. These are all deviations and these are all depth of rainfall. So here you have a time of concentration of 27.4. So if we come here, so 20, not 30, not 20, but more than 20. So it is 27.4. Now the corresponding depth of rainfall is there. So in case of 20, we see that there is a 40 millimeter rainfall for 20. For 30, there is a 50 millimeter rainfall. So what we have 27.4 is the duration. So we can write 27.4 as 20 plus 7.4. And also here the corresponding 40 is also fixed. So what we will do is we will just multiply the remaining portion of the duration, that is 7.4, into 7.4 into this slope of this part. Okay, so we have to find that slope. So how you can find it? You have to find that the corresponding rainfall of the duration 27.4. So this is not matching with it, but this is matching. For 20 you will get 40, then for 30 you will get 50. This is the interpolation. So what we'll do is we need the 27.4. What is whatever this. So what we did is 20 is there. So let us first start to find the slope. Slope will be defined by y upper minus y lower divided by x. Okay, so by this way, what will happen is this is our slope. Multiply with 7.4, and you get the duration of rainfall for the duration 27.4. Correct? And then here everything is okay. Then you have to find that rainfall intensity, that is I. 47.4 is the rainfall duration corresponding to 27.4, and so this will give you the I. So once you got the I, you have the C is already given, and you have to use the ratio rational equation. Okay, so you have C, you have A, and you have find out I. So that gives you the Q. And if you also divide this CIA by 3.6, then you will get Q in the unit of cubic meter per second. Okay.